Yeah.
Okay. Okay. Here in compressor also, you see volume is fixed here for every cycle of operation. Okay. In this volume, mass is entering and leaving. So what you see here in the open system, mass is fixed. Volume is fixed.
Okay.
For this volume, for every cycle of operation, mass is entering and mass is leaving. That means this volume is fixed here.
Yeah.
For every cycle of operation, this volume is fixed. Mass have to enter in this volume in every cycle of operation. So that means this volume is fixed. So you can call it here volume is controlled. Here volume is controlled. Mass is not controlled. Here mass is not controlled. Why? Because mass is entering the control volume or system. Mass is entering the system, so mass gets changed. Mass gets changed. Here mass does not remains constant because mass is entering, so mass will get changed. Okay.
Yeah.
So this is your control volume system. We call open system as control volume system. Okay. So let's move to the new point. Here, this is your turbine. This is your turbine. And mass is entering and mass is leaving. Okay. This is working substance. But here the volume is fixed. Volume is this. Volume is this. Okay. From this volume, mass is entering and leaving the system. So this volume is controlled here. So open system is also called control volume system. So our note point is for open system, volume is fixed.
Yeah.
Volume is fixed for every cycle of operation. For every cycle of operation, that means volume is controlled here. Controlled means fixed. Okay. Volume is controlled. Hence, open system is also known as control volume system. This is very important, my dear. Please remember this. Open system is also called control volume system. Very, very important. Okay.
Open system is called control volume system. Okay.
Okay. Now, my dear, this surface is called control surface. Control surface. Control surface means it is a fixed region. It is a fixed region in a space. From this region, the mass is entering the control volume and leaving the control volume. So this surface is called control surface. Okay. So when you are asked about what is control surface, then please tell this is the surface. This is the surface in a space from which there can be mass transfer and energy transfer between the system and surrounding. Okay. And this is your control surface. So it is a region in a space It is a region in space from which there can be mass transfer and energy transfer. Mass transfer and energy transfer between the system and surroundings.
Right.
Between system and surroundings.
Right.
Okay. And this is your control volume. This is your control volume. Now, my dear, now one more point is remaining here, which is very important to you. Let's get that point. Okay. Note. As you have studied in the closed system, let us assume this is your closed system.
Yeah.
Then you can easily call that system as that type of system in which there is no mass transfer. Mass transfer is zero, but energy transfer will be not zero. Okay. So this type of system is called closed system. Okay.
Yeah.
And what you have studied in open system? In the open system, both mass and energy transfer will take place.
Yeah.
Suppose this is your system, open system, and in the open system, you have studied that mass transfer and energy transfer both occurs. Mass transfer will not equal to zero, and also energy transfer will not equal to zero. So this is your open system. Now, my dear, now please compare these two systems. Please compare this two system. Then what you have understood from these two systems? What is the difference between these two types of system?
It's only the mass transfer for the closed system that's different.
Okay, mass transfer. What is the difference between these two types of system? Basically, mass transfer. Okay, in closed system, mass transfer is zero, but in open system, mass transfer is not zero.
Yeah.
When, my dear friend, in the closed system, please understand this concept. Please listen to this concept very carefully. In the closed system, when we allowed the system for mass transfer, in closed system, when we allow the mass transfer, then that type of system is called open system.
Okay.
Here the basic difference in the closed system and open system is due to mass transfer.
Yeah.
In the closed system, there will be no mass transfer. In the open system, there will be mass transfer. So if we allow in a closed system for mass transfer, then that type of closed system is your closed system becomes now open system. Let's take an previous example which I have taken. Let's take simply a cup of tea. And initially, what you will see, I have placed a plate over here. Then that time, this is your closed system. Okay.
Yeah.
Closed system. Here, mass transfer does not take place. When, my dear, when we remove this plate, when you remove this plate, then mass transfer will occur, and then this system will become your open system. When you remove the plate here, then that system is now your open system.
Yeah.
So open system is basically a closed system with mass transfer. When in a closed system there is mass transfer, then that system is open system. Okay, so open system is a closed system, but how? When in the closed system there will be zero mass transfer. So in the closed system there will be mass transfer. So open system is a closed system with a mass transfer.
Okay, I got that.
Because when in a closed system, if there is mass transfer, then it will become open system. Please see the example I have taken here. In the closed system, initially plate is placed on the cup, but when the plate is removed, then there will be mass transfer. So our initial closed system will now become open system. So open system is a type of closed system, but with mass transfer. You have studied about closed system. That this is a system in which no mass transfer taking place. But in the closed system, if there is mass transfer, then that system is now becoming your open system.
Yeah.
I hope this concept is clear to you.
Yeah, I am. I'm understanding it.
Okay, my dear. So this was your open system concept. Okay.
Yeah.
Now, please remember here. Please remember the example, all the example taken here, and in your daily life, whenever you see the device in which there is mass transfer, so then that device is your open system. Okay. Now let's move to the isolated system. This is your third type of system. Okay. Let's move to the isolated system. Here, then the name also suggests, please go through the name, isolated system. Here the name also suggests the system is isolated. Isolated means there is nothing to do with the surrounding. Whenever you call a friend that he is isolated, that means he has to do nothing about the surrounding. Okay, so that is the meaning of isolation. Okay, isolated. Then isolated means here the system has to do nothing about the surrounding. That means the system and surrounding, in the system and surrounding there will be no mass transfer and no energy transfer. If there is no mass transfer and no energy transfer between the system and surrounding, then that type of system is called your isolated system. Okay, that means system has to do nothing with the surrounding. There will be no interaction between your system and surrounding. Okay, so that system is called isolated system. Let's see the definition. When there is neither mass transfer nor energy transfer between the system and surrounding, then that system is called isolated system. Okay, let's see the image here. This is your isolated system and this is your surrounding. But you can see here there is no energy transfer and there is no mass transfer. So this system is called isolated system. Okay. And the example of this isolated system, as you are seeing in the image here, this thermos flask. This thermos flask is the example of isolated system. This is your system. This is your system, my dear. This is your system. Okay. And this is your surrounding. Here, what will you see? There is no mass transfer. There is no mass transfer, my dear, between the system and surrounding. And there is also no energy transfer. There is no energy transfer. That means ET is equal to 0, no energy transfer. So thermos flask is the example of isolated system. Okay. Because here between the system and surrounding, there is no mass transfer and no energy transfer. Okay. And when you assume, let's make a figure of insulated flask. Okay.
Yeah.
This is your insulated flask. Okay. And this insulated flask, let us assume a hot coffee is present. Hot coffee is present. Hot coffee is in this thermos, in this insulated flask. Okay. Then what will happen here? This is your insulated flask. So my dear, this system is insulated. This is your system. But you insulate this system. You isolate this system from the surrounding. That means this system has to do nothing with the surrounding. Okay. So here hot coffee is present. This is your hot coffee. So my dear, since this is hot coffee, so there may be a chance to get energy transfer between the system and surrounding, but you have insulated this flask. You have insulated this flask. Here you have insulated this flask, so there will be no mass transfer between the system and the surrounding. So here, my dear friend, there will be no mass transfer. Neither mass is entering the system or nor mass is leaving from the system. So there will be no mass transfer. And also there can be no energy transfer because you insulate this flask. Okay. So there will be no energy transfer. No energy transfer. Okay, my dear.
Yeah.
So this is the example of this insulated flask is the example of isolated system. Whenever you are being asked to give an example of isolated system, then please tell hot coffee in an insulated flask is an example of isolated system. Okay. Now, my dear, let's move to the new concept here. Let's move to the new concept here. I have told you about universe. This is your system. This is your surrounding. And I have told you in the previous session that system and surrounding both constitute your whole universe.
Yeah.
Okay. This system and surrounding is combinedly give the universe. So this is your universe. We want to know about the universe, that which type of system is this. Okay. So let's see here, my dear. In the universe, there can be mass transfer and energy transfer between the system and surrounding. There can be. Here mass transfer can be occurs. Okay, energy transfer also can occur or does not occur. There may be a possibility that energy transfer will not occur, mass transfer will not occur between the system and surrounding. Okay, okay. But in the whole universe, we have to know about the universe. Which system is this? Universe is what? Which type of system? So in the universe, there is no energy transfer. There is no energy transfer goes out from the system. Okay. There is no energy transfer from that goes from inside to outside of the system, or does not entering the system, or mass is also not entering and leaving the universe. So mass transfer is also zero here. Why, my dear? Why? Because we have considered the whole universe. So from whole universe, where this mass transfer goes? Where this mass transfer goes? If mass transfer occurs, then where this mass transfer goes? So there will be no mass transfer. And there will be also not energy transfer from the system or from the universe. Okay. So in the universe, there will be no mass transfer from the universe to the surrounding, because there is no surrounding present here for universe. Okay. So universe is a type of isolated system. Universe is a type of isolated system. Okay. I hope this is clear to you. Ramit, does this concept clear to you?
Yeah, it is. It is.
Okay, thanks. So these two examples are very important for the isolated system. First example is hot coffee in an insulated flask, and second example is universe. These two examples are for isolated system. Okay.
Yeah.
Now one more concept is remaining here for isolated system. Note, as we have seen in the open system, that open system is also known as closed system with mass transfer. Okay, so here you can also relate this isolated system with the closed system. We know, my dear, when this is closed system, when this is your closed system, then here mass transfer is zero. Mass transfer is zero for closed system, but energy transfer is not zero. And in isolated system, as you have studied here, if the system is isolated, then what will happen here? Then here there will be no mass transfer and no energy transfer. Mass transfer is zero and energy transfer is also zero. Energy transfer is also zero. Then please compare these two systems here. Energy transfer is also zero. Please look at these two. Please look at these two systems carefully here. In closed system, mass transfer is zero. Okay. In isolated system, also mass transfer is zero. Okay. But in closed system, energy transfer is not zero. But in isolated system, energy transfer is zero. So if in the closed system, there is no energy transfer, if in the closed system there is no energy transfer, then that closed system is called isolated system. For example, my dear, for example, I have taken an example of cup of tea. Okay, and you put a plate over here. So this is your closed system. Now in this closed system there is energy transfer. If this energy transfer which is occurring in the closed system, if we reduce this energy transfer to zero, then this system is called isolated system. But how we can reduce this energy transfer to zero? Okay, so we insulate this cup of tea. When you insulate this cup of tea, my dear, then what will happen? Then no energy transfer will occur. No energy will go out or into the system. So energy transfer will be zero. Okay, and mass transfer is also zero. Okay, so this closed system now becomes as isolated system, because in the closed system energy transfer will be taking place, but we restrict this energy transfer by providing a insulation all around the cup of tea. So there will be no energy transfer, and that closed system is now behaving like isolated system. Understand, my dear? Ramit, is that clear?
Yeah.
Okay, so we can call this isolated system is, so isolated system is basically a closed system
Yeah.
without energy transfer.
Okay.
Without energy transfer. When in a closed system, when we restrict the energy transfer, then that means your system is now behaving like isolated system. Okay, yeah. So isolated system is basically a closed system without energy transfer. Okay, yeah. Now my dear, in isolated system, you are seeing the concept here, that isolated system, it is basically a closed system with without energy transfer, and open system is a closed system with mass transfer. Yeah. When in the closed system there will be mass transfer. If we want in the closed system to do mass transfer between the system and surrounding, then that closed system is your open system. But when in closed system, if we restrict the energy transfer, then that system is called isolated system. I hope, my dear, this is very clear to you.
Yeah, it is.
This is very important concept. Okay, so I hope today's session is enough for you. Okay.
Yeah. So the next session, is it on the weekend or is it?
Next session, Thursday. Next session will be on Thursday.
Okay.
Okay, my dear. Next session will be on Thursday, and please remember all these. Please revise all these concepts regularly.
Yeah. I'll go for the notes after this. Yeah.
Okay. Please revise carefully and on a regular basis, so your concept will be automatically good. Okay.
Okay.
So my dear, thank you for this session. Okay. So
Thank you.
let's meet on Thursday. Okay.
Okay.
So, thank you, my dear. Thank you.
Okay. Bye.
Bye.